Let's have a look at question number 18 from the 2013 Revised Higher Physics paper. It says the capacitance of a capacitor is 1000 microfarads. I'm just going to take a note of all of these things on the right hand side here. So the capacitance is 1000 microfarads. That's 1000 times 10 to the minus 6 farads. The potential difference across the capacitor is 100 volts. So V is 100 volts. And the charge stored by the capacitor, which is Q, is 0.10 coulombs. And then it says the charge on the capacitor is now reduced to half its original value. So we'll write that over here. So this is maybe at the start and this is at the end. And the new charge is half its original value, so that's 0.05 coulombs. Which row in the table shows the capacitance of the capacitor and the PD, the potential difference across the capacitor, for this new value of charge? Okay, well the first thing to note is it's the same capacitor, so therefore it will have the same capacitance. So that means that A could be right, C could be right, and E could be right. Question is, which one is it? Right, so the potential difference. So what happens to the potential difference? Well, I'm just going to write over here that the capacitance is the same as it was before, 1000 microfarads. And we're trying to find out what the new potential difference is. So there's two ways to think about this problem. One is to use the equation, which is Q is equal to CV, i.e. the relationship between charge, capacitance, and voltage. I always remember this formula, by the way, either by saying you need lots of qualifications, Q for a good CV, or another way of remembering it is that Q in James Bond always deserved the Victoria Cross for his work and services for the British Empire. So either of those two ways of remembering are fine, whatever works for you. So let's rearrange the formula. V is Q divided by C, and therefore we can plug in the numbers, which is 0.05 divided by 1000, and that's 1000 microfarads, so it's 1000 times 10 to the minus 6, and that gives us the voltage for this new arrangement of 50 volts. So our answer has to be E. Now, just another way to think about this, of course, is to think about a graph. So let me just bring up a line. So if we had a line graph drawn like this, and on one axis we had charge, and the other axis we had voltage, the line would be a straight line through the origin, like that, and that shows the relationship between charge and voltage for a capacitor. And what that shows is that these two are directly proportional to one another. So if the charge reduces by half, that means the voltage will also reduce by half. If the charge was originally, say here at 0.10, and that provided a certain voltage, which was 100, if the charge went to half, 0.05, then the voltage would drop to half, which would be 50. So that just confirms what we calculated as well, and it's just another way to think about the problem. So definitely the answer is E.